Ever heard a client demands centimeter-level precision in a hospital ward? Sounds impressive, right? But what if the physics just doesn't allow it with the constraints they've set? That's where we start. So the client wants 15 to 20 centimeters. Cute. In a perfect lab, maybe. But throw in real-world chaos, reflections off metal beds, people walking around, signal blockage, and you're looking at sub-meter accuracy, maybe even worse. Our expert, Mr. Yue, cuts through the noise. Single AO base station? Forget it for that kind of precision. Ceiling height alone limits your effective range. This isn't about promising impossible things. It's about understanding the fundamental trade-offs. Deployment cost, environmental cost, usage cost, these are the non-negotiables. Precision isn't a magic number. It's an engineering outcome born from these factors. Let's be honest, chasing that 15-centimeter dream here is a recipe for disaster and budget overruns. Okay, so we kill the impossible dream. What's the smart play? First, understand the real goal. Correctly identify which bed the thermometer is at, and automatically bind the data. Does that require 15 centimeters? Absolutely not. 30 to 50 centimeters, sub-meter level is plenty. So, how do we get there? We ditch the single base station fantasy. 2 AO base stations strategically placed. Then we use a fusion approach. Think geofencing, defining rough areas, applying known bed positions as constraints, smart filtering algorithms, and built-in business tolerance. It's not just one trick, it's a combination. The result? 100% bed distinction, automatic data binding achieved reliably. We meet the actual need without breaking the laws of physics or the bank. How does this actually work under the hood? It's a layered system. At the bottom you have the terminals, the tags or thermometers themselves, equipped with positioning modules. Above that, the hardware layer, our AOA Bluetooth base stations. The crucial part is the engine layer. This is where the core positioning algorithms reside, doing the heavy lifting of AOA fusion calculations. Then comes the platform layer, electronic maps overlaying the real-time location engine. Finally, the business layer integrates this all into the specific medical software, handling bed binding logic and data archiving. It's a complete stack, designed for deployment and integration. So, what's the big picture takeaway? First, ditch the hype. We focus on deliverable engineering. Second, always tackle risk first, diagnose the scene, define realistic metrics, then propose solutions. Third, keep the user's core business need front and center, not some arbitrary parameter race. Fourth, remember that true precision often comes from fusion, combining hardware, smart algorithms, accurate mapping, and tailored business logic. And finally, the golden rule, verify everything with field tests before signing off on anything. That's the core IoT way.